Good day, I'm Maile Matsiba. Welcome back to our channel. Today we continue with the 2017 study guide of our CIR 113. We're looking at example 2.9.4. It says a gauge pressure on a gas cylinder in Pretoria is 300 kilopascals. It also highlights that the atmospheric pressure in Pretoria is 87 kilopascals. It goes further to say the cylinder transported to a campsite at the coast, and the coast have an atmospheric pressure of 1010 millibars. The question is, what will the gauge pressure on the cylinder be? Now it also highlights that it says assume that the temperature remains the same. Now, to be able to answer such a question, we'll have a couple of steps to actually attend to it. So the first step 1, we will calculate the absolute pressure in Pretoria. Let me just write and say calculate the absolute pressure in Pretoria. So that is actually our step 1. And can I just write here and say in Pretoria, especially because I'm going to be doing a lot of duplicate calculations. So in Pretoria, we can say absolute pressure equals to gauge pressure plus atmospheric pressure. So we have the equation. It says the absolute pressure equals to the gauge pressure plus the atmospheric pressure. This is the equation that we know and we've been given. Now we know that our gauge pressure, it says that it's actually, our gauge pressure is actually 300 kilopascals, which means we're gonna be saying 300 kilopascals plus our atmospheric pressure in Pretoria, remember, it's actually 87 kilopascals. This means our absolute pressure equals to 387 kilopascals. So that is actually our first step where we calculated the absolute pressure. Now the second step, we can say step 2, we're actually going to calculate the atmospheric pressure in kilopascals at the coast. We have the atmospheric pressure, but we've been given it in millibars, so we're just going to be converting this into kilopascals. So we can say calculate the absolute absolute pressure. Calculate the absolute pressure at the coast in kilopascals. Now we already have the atmospheric pressure at the coast, but it's in millibars. We're just going to doing a conversion to kilopascals, and we'll just say, okay, let me say at the coast, just so that we don't confuse things. Let me say atmospheric pressure equals to 1010 millibars. My handwriting is happening again. 1010 millibars. And for us to convert millibars to kilopascals, we can just take a couple of steps. We can just say 1 bar. We know that a milli is 1,000, so we know that a milli is actually 0.0001. So we're going to say 1 bar over 1,000 millibars. Now we know for sure that the millibars will fall off, but now we're left with the bar. Now we can continue further to say, how do we convert the bar into kilopascals? And we can say 101.325 kilopascals all over 1.013 bar. So with that said, the millibar falls off, also the bar falls off. We'll be left with 101 kilopascals. This is atmospheric pressure at the coast. It's 101 kilopascals. Can I write here? I hope it will fit well. Just here that 101.325 kilopascals equals to 1.013 bar. And yeah, for space purpose, I'll just assume that everybody knows that a millibar is actually 0.001. So it should be easier. Now that we have this, we're going to be going to our step 3. We're going to be saying step 3, calculate the gauge pressure on the cylinder at the coast. So yeah, so we actually now are answering the question. Remember, the question says, what will the gauge pressure on the cylinder be where at the coast after the cylinder has been transported from Pretoria to the coast? So now in step 3, now that we have put together all the information we need, we're going to be calculating, or rather answering the question, which is calculating the gauge pressure. So we can just continue also and say at the coast, we can say gauge pressure equals to, or let me just write the original equation just so that everybody can be able to follow. Let me say absolute pressure equals to atmospheric pressure plus the gauge pressure. Right, so that is actually the original equation, that atmospheric pressure equals to the absolute pressure equals to the atmospheric pressure plus the gauge pressure. Now rearranging, we can have the gauge pressure as the absolute pressure minus, because we're taking this one here, minus atmospheric pressure. Now that equals to, we know that our absolute pressure, we have actually calculated it to be 387. And another important principle that we need to highlight is that the absolute pressure has everything to do with the number of moles in the cylinder. It never changes, so the absolute pressure will always remain 387 kilopascals. Wherever you take the cylinder, it doesn't really matter until you change the number of moles. Either you add some more of the moles in the cylinder, or you withdraw some. Then we can talk about the absolute pressure changing. But as it stands, our absolute pressure even at the coast is still 387 kilopascals. And then we minus the atmospheric pressure. We found it to be 101 kilopascals. Now our final answer becomes 286 kilopascals. Yeah, so that becomes our final answer. So that is actually how to answer the question. And thank you for your time. I hope we meet again in our next video.